Okay, kia ora Year 9s. This is Mr. Daly. I'm just making a video of one of the past mid-year exams so that I can help you study while you're at home. So, first things first, in Schoology, there's now a purple folder called Mid-Year Revision. So if you click into there, this file here is the test that I'm going to go through. It's from 2017, and if you click right here, this will be where the video is, but if you're watching the video, then you probably have already found it. Alright, so without further ado, let's go check it out. So, percentages. If you're trying to find a percentage of something with a calculator, what you want to be able to do first is change your percentage to a decimal. So that's just moving the decimal point 2 over. And if you ever see of, generally you're going to multiply your numbers together. So in your calculator you would do 0.42 times 350, and that's your answer. So 42% of 350 is $147. Okay. Next question. The number of minutes in 6.5 days. Okay, so first of all, 6.5 is 6.5, right? 6.5 days, and in a day there are 24 hours, so we're going to multiply by 24, and there are 60 minutes in a hour. So 6.5 times 24 times 60 will give us our answer. 9,360 minutes. Okay, this next one. Now, this is very easy to do if you have a calculator. If you don't have a calculator, what you want to do is you want to do these, the top and the bottom first. When you get something like this, really there's like invisible brackets that need to be sorted out before you do any division. So if you did this in your head, you get 23 plus 9 is 32, and 9 minus 5 is 4, so we have 32 divided by 4, which equals 8. But you can just put it all in your calculator, so if I press this fraction bottom, that'll allow me to just put it all in directly, so I can get everything up the top. And using the replay button, you can skip along to the next box. So we got 9 minus 5, and if we hit equals from there, that'll also give us 8. So either method is fine. Square root of 47, round to 2 decimal places. Let's do that. So on your calculator, this button here is your square root button, so we'll hit that and type in 47 and hit equals. So this is quite often what happens on most calculators. It doesn't actually express it as a decimal right away. So what you want to do is hit this S to D button. Might be a different letter, but that'll change it from a square root to a decimal. So we want this to 2 decimal places. So we're looking at this 5 and the number before it. It's above a 5, so it's going to round up that other 5. So our final answer will be 8.86. So 2 decimal places. I'm just going to change my pen to a skinnier one. It's a bit thick. Alright. This next one, if we're thinking bed mass, then, well, we've got no brackets, nothing going on there. Exponents, we do have 5 to the power of 3, so that will actually get calculated first. So the first step is to go 75 minus 4 times 5 to the power of 3 will be 5 times 5 times 5, so 125. So that would be the first step, and then the next step is multiplication. So you forget about the minus, just leave it there for the moment. So we do multiplication next, so 75 minus 4 times 125 is going to give you 500. And then 75 minus 500 will give you negative 425. So your calculator is actually capable of doing all the bare maths as well. So if I just put that in, I should end up with the same answer. But I just wanted to show you, whoops, we want to make that 5 to the power of this button here with the X with a little square is how you can get to the power of 3. Yep, and then we hit equals negative 425. So we were correct there. But it's good to know that your calculator is always doing bed maths. Alright. Next one, negative 6 times 42. You can just chuck that into your calculator, times 42, negative 252. 56 divided by negative 7, 56 divided by negative 7, negative 8, easy. Next one, negative 4 times negative 5. Whoops. See how I've got this answer up here? You've got to be careful with that, because that's holding the last thing I've calculated. So it's technically got this negative 8 in the background. So sometimes it's better to use this negative with a bracket in it, because if I just hit that, it's cleared the answer. So that will work. That's it. Even though it's a shorter negative, it's still the same. So negative 4 times negative 5 times 6 will give us positive 120. The two negatives end up cancelling out. Alright, next one. What do you have to divide 60 by to get 0.5? Alright, so if we had 60, we want to divide it by some number. We're going to get 0.5. So a way of thinking about this would be to change division to fractions. So another way to express this would be 60 over x equals 1/2. So actually this is an equivalent fraction to 1/2. So when we've got equivalent fractions, another equivalent fraction would be 2/4, or 5/10. So what happened? So 5/10 is still, these are all different ways of representing 0.5 as a fraction. So what happened when we went to this one? We multiplied by 2, multiplied by 2, and for the other one we multiplied by 5, multiplied by 5. So really, if we're thinking about going from 1 to 60, we've multiplied by 60. So if we wanted to know what x was, we would also multiply 2 by 60. So x is going to equal 120. That's just one way of thinking about it. There's lots of ways. Another way is you can swap the 0.5 and x around, and you'll get the same thing. If we put that into our calculator, 0.60 divided by 0.5 will also give us 120. That's kind of a little bit harder to understand maybe. Alright, the cost of petrol is always changing, and last month the price of 91 octane petrol was $2.05. This month the price has gone down by 4%. What is the price of a litre of petrol this month? Show you working. So if we wanted to work out 4% of 2.05, we simply multiply by 0.04. So that is 4% as a decimal. Right. So 2.05 times 0.04 equals, we don't want it as a fraction, that's not any use to us, we want it as a decimal, so that is 0.082 off. So that's not our final answer, that's how much it's gone down by. It's gone down by 4%, so that's the 4% that we want to take away. So we just take our 0.205 and we're going to subtract it away. So 2.05 minus 0.082, use our fraction to decimal button, it's going to give us 1.968 dollars, and I guess it's per litre of fuel. Alright, next one. Write the following decimals as percentages. Okay, well, this is relatively easy. We just want to, if we're doing it on a calculator, going from a decimal to a percentage is simply multiplying by 100, because that's what percent means, per 100. So 45% per 100. So another way of thinking of it is it's 45 out of 100 as a fraction. So if I put that into the calculator, I'm going to get back to our decimal, 0.45. So these are relatively easy. Once you know what your digits are, it's just going to be that moved over 2. So 78%. This one here has got 3 digits, but doesn't make it any harder. We're going to move it 2 over to get 13.5%. So you can, just because it's a percentage doesn't mean there can't be a decimal point in it. Your decimal point has just been moved twice. So move twice. Alright, write the following percentages as decimals. So this is like going the other way. So there's where our decimal point was, and if we want it to move 2 over, so it's going to be there. So 0.23, or if you did it on a calculator, you could go 23 divided by 100. So we're going back the other way where we divide. There we go. See how it showed it as also out of 100. So those are all the same. 23%, 0.23, and 23 out of 100, all the same. So for this one, we're going to move it twice, so it's going to end up there, 0.325. And actually, if we put that into a 32.5 divided by 100, that's going to give us a slightly different one. But you can see, so 13/40ths is actually the same. But another way of thinking of it is we've got 325 divided by 1,000. Alright. Round the following decimals to the number of decimal places in the bracket shown. Okay, so this one wants us to go 2 decimal places, this one wants us to do 1 decimal place, and this one wants us to do 3 decimal places. So that just means that we've got 3 digits after the decimal point. So what you need to do with these ones is look at the number before it. Is it bigger than 5? Or is it 5 and above? Then that means it's going to round up the next one. So for this one, it's going to round up our 9. But if we rounded up our 9, it would go up to a 0. And so that is actually going to carry over an extra one. So the final answer for this is actually 4.90. So we've still got those 2 decimal places. But sometimes you get that situation if you're rounding up a 9. The next one, it only wants 1 decimal place. So if we take that 9 and round it up, we are going to get 42.3. It's nice and easy. This one here, the number before our 3rd decimal place is a 4, which is lower than 5. So it doesn't actually do anything. It doesn't have any effect on our number. Nothing gets rounded up. So our final answer is 6.983. So we just remove the 4 rather than it having any rounding effect. Alright, number 8. Use your calculator to find the answers to the following questions. So we used this button before, the X with a little square box above it. Sometimes that box looks like, so you can either use that to get your exponents, or sometimes there's a little up arrow for some calculators. So it depends what calculator you're using. And also some calculators use this X with a little Y up there. So you have 3 different buttons possible depending on what calculator you got. But the one I'm using, and most of you will be using if you've got a Casio, has this X with a little box above it. So to use that, well, we need to hit 4 first, and then our exponent, and then 5, and that's done that. What you need to be careful of is if I press plus now, see how it's still typing within the exponent box. So what you want to do, just delete that, and the replay button at the top, if I hit that, now I've moved the cursor so it's no longer typing within the exponent box, so I can finish off the rest of putting into the calculator. So that's going to give us 1,240. So you really want what you've put into the calculator to look exactly like it is on the thing, and it should be okay as if you make it look exactly the same. All right. Next one, 7 to the power of 5. Move that down, minus 5 to the power of 6 equals 1082. 23 to the power of 5, this is going to be a big number, I can tell. So that essentially is, you can imagine doing 23 times 23, that would be about 500 just by itself, but by doing to the power of 5, we're going 23 times 23 times 23 times 23. So that's saying we're getting 64336. 343. So I always write the whole thing out, and then I come back and put some commas in, so it's easy to say what the number actually is. So 6,436,343. So the comma is when you say million, and then this comma is where you say thousand. I just wanted to prove that 23 to the power of 5 is just 23 times 23 times 23 times 23 times 23. See, same number. So, but you can save yourself some time by just making using your exponentials. Alright, number 9. Round each of the following numbers in the following questions to one significant figure and then do the calculation to give an estimation of the answer. Okay. So you really have to know what one significant figure means. So a significant figure is a different way of rounding other than decimals. So, but it's generally used for big numbers. So if we had a number like 1,000 or 12,345, if this was to two significant figures, then we would have these first two digits hold the most value. The 1 is worth 10,000, the 2 is worth 2,000, the 3 is worth 300, the 4 is worth 40, and the 5 is just worth 5. So the numbers on the left have more value, they're more significant than the numbers that are to the right. So this to two significant figures would be 12,000. You just fill the other digits with zeros. So these are the two significant figures, and then everything else just becomes zeros. So with 60 to one significant figure, or 63, that's going to become 60, and 46, this 6 will round up 4, so we're going to have 60 times 50. So that'll give us a pretty accurate estimate of 63 times 46. So 66 times 5 is 30, and then we're just going to put those two zeros on. That'll get us 3,000. So I'll just prove that that is the case on the calculator. 3,000. Now you will get this question wrong if you just put into your calculator 63 times 46, because you're not actually reading the question properly. So please be careful with this one. I don't want you to lose an easy mark. So if you just did 63 times 46 and you wrote in 28,000 or 2,899, which you can see is pretty close to 3,000, you'd actually get that wrong, even though that's the exact answer. What we're looking for is this 60 times 50 answer. Hopefully that made sense. Alright, so the next one, we're going to do the same thing. So to round this to one significant figure, the 8 would round up the 9, which would then round up the next digit, which is a 0. So this is going to be 100 divided by 20, because the 3 doesn't round up 2, because it's below 5. So 100 divided by 20 will equal 5. Prove that on the calculator. Alright, so you would not get the answer right if you did just 98 divided by 23, because you haven't rounded it to one significant figure. So if you put 4.26, you'd be wrong. If you put 5, you'd be right. Okay, I think that's the end of our number section. Oh no, we got a few more complicated ones. Lowest common multiple of 4, 5, and 9. So really, first you need to know what multiples are. So multiples of 4, we've got 4, 8, 12, 16, 20, 24. So I'm just counting up in 4s. These are the multiples. So multiples of 5, we've got 5, 10, 15, 20. See, there's one that we have in common, but I don't think we'll have it for 9. So what am I thinking we might do is start with 9 because it's our highest one and just count up in 9. So we got 9, 18, 27, 40, 36. So 36 will actually be a multiple of 4 eventually, so it's there and there, but it's not a multiple of 5, so that's not what we want just yet. 45, 54, 63, 72, 81, 90. Alright, we've got to 90. So 90, we know, will be a multiple of 5 because all multiples of 5 end in zeros or 5s. So that'll be a multiple. There'll be a 90 in there in the multiples of 5. So that's really the first one that we can check. Oh, we could have checked 45. But 45 will not divide by 4, so that's not going to work either. So let's just try 90s into 4. So 90 divided by 4 is 22.5. So still no. But if we doubled that, get 180. Which I think is just what you get when you multiply 4 times 5 times 9. You're going to get 180. So that will work. So 180 divides by 4. 180 divides by 5. Yep. And 180 divides by 9. Or just multiplying 4 times 5 times 9. If in doubt, just do that. And you should be golden. Alright, write down the next 3 prime numbers that come after 47. So, with prime numbers, they are numbers that cannot be divided by 2, 3, 5, or 7. Because those are the first 4 primes. Eventually, when you get into the hundreds, you have to check 11 and 13 as well. But for the early numbers, between 0 and about 200, you can just check by dividing by the first 4 primes, 2, 3, 4, and 7. So 47, I believe, will be a prime number. We can check this by dividing by 2. If it divides evenly, then it's not a prime number. Doesn't divide evenly. 47 divided by 5 doesn't divide. 47 divided by 7 doesn't divide. So that's a prime number. Whereas 49, so it's best to just check all the odd numbers. There's no point checking even numbers because we've got 2. So you can just do that in your head, really. So 49 divides by 3. Nope. 49 divides by 5. Nope. 49 divides by 7. Yes, it does, because 7 times 7 is 49. So it's not 49. We'll just cross off 49. Next possible one could be 51. So let's check that. 51 divided by 3, 17. So it's not that. 3 times 17 is 51. The next one after that, 53 divided by 3, doesn't go. 53 divided by 5, doesn't go. 53 divided by 7, doesn't go. So 53 is a prime number. prime. 55, that's going to be divisible by 5, so no. 57, let's try that. 57 divided by 3 is 19, so that also doesn't go. 59, let's try 59. 59 divided by 3 doesn't go. 59 divided by 5 doesn't go. 59 divided by 7 doesn't go. So 59 is a prime, it's our next prime. Alright, next one after that, 61. 61 divided by 3 doesn't go. 61 divided by 3, divided by 5 doesn't go. 61 divided by 7 doesn't go. So 61 is also prime. So just going back, 49 was 7 times 7, 51 was 3 times 17, 57 was 19 times 3, 55 was 5 times 11, whereas 53, 59 and 61, they can only be made by going 1 times themselves, which isn't enough to be significant. Alright. Lowest common factor of 36 and 72. So, I think this is actually supposed to be highest, because it's like directly opposite the earlier one with the lowest common multiple. So the lowest common factor would, well, be 1, because every number has 1 and both these numbers have 2, so that's probably just a bit of a typo there. So I'm going to work this out for the highest common factor, so disregard that, it should be highest. So for 36 and 72, what are our factors? Well, we can go 1 times 36, 2 times 18, 3 times 12, can we do 4? 4 times 9, can't do 5 times anything because it doesn't end in a 5 or a 0, so we got our last one is 6 times 6. And once you get to a point where both of them are the same, you've actually listed all the factors. So that's all the factors of 36. Factors 36, factors 72, we have got 1 times 72, 2 times 36. Well, I think we've got it right there. 36 and 36 are the highest numbers that both 36 and 72 will both divide into. Of course, we could go further with 72. You've also got 3 times 24, 4 times 18, 6 times 12, got 8 times 9. Yeah. Alright. Moving on to our algebra. Just might rub that out so it's on the way. Okay. Solve for x. Show you're working. 5x plus 7 equals 42. So, with your working, what we're looking for is each time you do an operation to both sides, you show that. So, the first thing we want to do is take away 7 from both sides. So we're going to do a take away 7 here, take away 7 here. That's going to leave us with 5x equals 42. Alright, I'm just going to write that again so it's more clear. So once we've got 5x equals 42, well hold up. We've got to take away 7 from 42, so that is 35. So next step is to divide by 5, both sides, because 5x means 5 times x, so we want to reverse timesing by 5, so we divide by 5. And that's going to leave us with our final answer of 7. Okay, for B, so we had a divide by 5 step there at the end. The first step here, it's going to be to expand. Whenever you see brackets in algebra, you should expand them. 3x minus 12 equals 36. So remember, this 3 multiplies the x, and it also multiplies the negative 4. So that's 3 times negative 4 gives us negative 12. That's how that came about. And then we're just going to do the same process. So we're going to add 12 to both sides. So there's our plus 12, plus 12. Oh, that didn't come out very good. Will leave us with 3x equals, so those cancel out. 36 plus 12 is 48. Then we want to divide by 3 on both sides. So we're going to divide by 3 step, which allows us to cancel those 3's on that side, and on the other side 48 divided by 3 is 16. This one, x divided by 7 equals 5. So to reverse a divide by 7, we need a multiply by 7. So we've got 7 times 7 there, times 7 there. So that was our working step, multiplying both sides by 7. Those 7's will cancel and leave us just with x on that side, and on the right side we have 5 times 7, which is 35. X equals 35. Alright, D. So, most common mistake I see students do is they forget entirely about Bez Maths. So, they just straight up add those together. But, what you want to do is expand first, because there's a secret multiply inside there. This really means 6 times this entire bracket. So we want to do the multiplication first. So let's do that. 13 plus 6x, 6 times negative 3 makes negative 18 equals 25. Okay. Alright. So what we have is a positive 13 and a negative 18. So those are what we call like terms, because they're all numbers, right? So I'm just going to put those together. You could use your calculator if you're unsure. Negative 18 plus 13 gives us negative 5. So we got negative 5 equals 25. Okay, now it's something familiar. So our first step was expanding. Always expand the bracket first if you've got brackets to expand. Then the next step we added like terms. So the positive 13 and the negative 18 became a negative 5. Our next step after that will be to add 5 to both sides. So we're going to add 5 both sides of the equal sign. And that'll leave us with 6x, and our negative 5's are going to and our positive 5 is going to cancel. and leave us with 25 plus 5 is 30. Divide by 6, divide by 6, we're going to get x, so that's a divide by 6 step. X equals 5. So 4 steps in there, so I think you would get 2 or 3 marks for that question. Alright, let's move on. Okay. If A equals 4, B equals 6, C equals negative 5, and D equals 2, calculate CD. So CD means C times D. You got to remember there's an invisible multiplication sign in between the letters. Okay, so really we have negative 5 times 2. So if we put that in our calculator, times 2. So doing these on your calculator can be really handy for those of you who are not too sure about what your answer is going to be. So always just use your calculator if you're unsure. You could have done that in your head, and you will if you have done enough questions. That's fine. So this one here, we have an invisible multiplication between the 2 and the a, so really this is 2 times a squared. Right? So a in this case is 4, so we have 2 times 4 squared. So if we put that into our calculator, we're going to get 2 times 4 squared equals 32. See how it's done the exponent first in our calculator, because if it did 2 times 4, that would be 8. 8 times 8 would be 64. So what has it actually done is done this part first. It's done 2 times 4 times 4 is 16. So 2 times 16 is 32. So just be aware that your calculator is always doing BEDMAS. So if you plug everything in exactly as it is in your calculator, then your calculator will sort out the BEDMAS for you. Alright, so this next one, what we're going to put into our calculator is exactly this, but with direct substitution. So B is 6, A is 4. So we've got 6 minus 4 in that bracket, multiplied by negative 5 plus 2. So if you're pretty confident with your BEDMAS, you can just do it in your head. So 6 minus 4 is just going to be 2. And negative 5 plus 2, that'll be negative 3. So we should get negative 6. But what I wanted to show you is you can just put that whole thing into your calculator. So let's do that. 6 minus 4 times negative 5 times plus 2. That's exactly as we have it here. Just hit equals, we get negative 6. It's the same. So your calculator does all that BEDMAS for you, as long as you get everything in the correct spot. So just double check to make sure you got your numbers in the right place. Alright, moving on. So with algebra like this, it works basically the same as numbers. So this is sort of like we've got 8 minus 1 plus 2. But you could think of it like we have 8 houses, we take away 1 house and add 2 more houses. How many houses have we got? We have got, well, something just moved. We've got, that'll be 7 houses once we take 1 away, and then we add 2, we're going to get 9 houses. This next one, we've got 4 cats plus 9 plus 5 cats minus 3. So cats can be added to cats, so we've got 9 cats altogether, and then 9 minus 3, those are numbers, so we keep them together, so 9 minus 3 is 6, positive 6. Now you might remember before when we did 23 times 23 times 23 times 23 times 23, that was the same as 23 to the power of 5. So this is almost exactly the same problem, except we have an s instead of 23. So our answer is s to the power of 5. Sometimes I like to put a little line there just to show that it's not a 5, it's an s. It can be hard to tell the difference sometimes. Okay, this one here, we have got, what starts with K? Kites. One kite plus another kite gets 2 kites, plus another kite is 3 kites. Take away one kite, we're on 2 kites, plus another kite, we're back to 3 kites. 3 kites. K for kite. Where are we next? Expand. We've done a lot of this already. So remember, the 9 multiplies both things inside the bracket. So 9 times x, 9x, 9 times negative 7, negative 63. Alright, this next one wants us to expand first and then simplify. So that's why they've given us 2 lines. So if we just focus on this first bracket, 4 times x, 4 times 5 is 20. And then we're on to that second bracket, 2 times x, 2x, 2 times negative 8, negative 16. Alright, so now we have got x's go with x's. So we've got 6x, and then numbers go with numbers. So 20 minus 16 makes positive 4. So when we combined our so this second line of working was our simplifying. When we're adding our like terms together, our 2x and our 4x, we make 6x. Our 20 minus 16 gets us positive 4. Alright. For the following equation, write out the algebraic techniques to solve them. A number. Alright. Let's call it a number C. So let's start off with C. Has 7 subtracted from it. Take away 7. This result is then multiplied by 4 to give a value of 64. So this result, if we want to keep that all together, we put some brackets around it. So this result, that's our result right there, is multiplied by 4. So we want to multiply all of that, the C, take away 7 by 4. So remember, there's an invisible multiply outside that bracket. And that gives us a value of 64. So now we're going to use algebra to solve this. So let's expand our bracket. We're going to get 4c, then 4 times minus 7 minus 28 equals 64. So expand. Now we want to add 28 to both sides to cancel out the 28. So those are gone now. So we're going to get 4c is equal to 64 plus 28 is 92. Now we want to, so that was our plus 24 on both sides, and now we're going to divide by 4 on both sides. So If I divide by 4 here and divide by 4 here, then that will cancel out the 4's on the left. On the right, that's something that we could put into our calculator. 92 divided by 4 equals 23. So C equals 23. And I think if you think of 23 in here, you could check it in your calculator. 4, let's just type in as you would see it. 23 minus 7, what does that equal? 64. So we were correct. Okay, last few. Write out the following using indices. So this is very much what we did over here, except there's 4 d's multiplied together, so that would d to the power of 4. Now, we've got a mixture of s's and d's here, so we've got 3 s's all multiplied together, so that will be s3, and then we've got 3 d's multiplied together, so then that's times d3. And in algebra you don't actually need this multiply here, so you can, though that is correct, it's just better to have s3 d3. That means 3 s's multiplied together times 3 d's multiplied together. Alright, this one here, Waipukura, we basically want to count up all the letters that are similar. So we got, if we just start with W, are there any more W's? No, so we'll just put a dot. That means multiply. So a dot is another way to display a multiply in mathematics. So next we've got A. Do we have another A? We've got 1, 2. So I'll just cross them out so we use all the letters. So this is going to be A squared. I. We don't have any more I's. Then we've got P. There's no more P's. Next is U. We've got a U. We've got 3 U's. So we're going to have U cubed. Then we have 1K and 1R. K and R. So there we have it. It doesn't matter which order you have it. If you want, it is kind of good form to put everything in alphabetical order. So if you were to do that, it would look like this: A squared, I, then what comes next? K, P, R, U cubed, W. So that's alphabetical. And those two are the same. They're all equal actually, but the simplification is in putting these letters together into A squared and U cubed. Alright, Mississippi. We'll try the same thing here. So only one M. There are 1, 2, 3, 4 I's, so we have I to the power of 4. Next we have 1, 2, 3, 4 S's, S to the power of 4, and then we have 2 P's, P squared. Alright, that concludes the algebra and number sections of the mid-year exam. 2017 actually did a measurement instead of geometry, so all this revision we have done the previous week on geometry should come up in the exam, and it should be pretty basic. But that's all for now. Hopefully you guys watched this video and it really helped with your understanding and helped with your study. Alright, catch you on the flip side.